and welcome to all of you. I appreciate you taking the time. I want to talk today about some of the things that we've learned over the last 20 so years that I've been doing this in terms of looking for operational improvements, making sure that efforts around trying to find areas and opportunities for improvement are focused as well as can be. A couple of things that I'm hoping to deliver as I go through some of these lessons is discovering value in previously unknown opportunities. One of the interesting things is when you're looking to improve, you're actually looking for trouble as opposed to reacting to it. So looking for things that you've not previously seen, and looking in not only the business processes, the assets or the production facilities, and also human performance. So we'll talk a little bit about how to find opportunities in all three of those. Looking at data that is relevant versus merely interesting. There's typically no shortage of data that you could look at. Some of it obviously is more important and relevant to look at than others, and we'll talk about how to stratify the data you look at and why you're looking at it. Also looking at cause versus severity of effect, and using that to select and prioritize your improvement efforts in terms of designing solutions and implementing them. Setting improvement goals based on best demonstrated performance, so you're looking for positive deviations. If you've got what should be a optimally designed process, trying to find out and identify why sometimes it works better than it does at other times. And then finally, looking at choosing opportunity targets based on their potential contribution to operational improvement objectives. And we'll talk about how to make sure of all the things you can and should fix and do, making sure you're focused on the ones that are going to give you the most return on your investment. So just a general sort of approach to operational improvement, just for context. Essentially, when we go in and work with organizations to improve their operations, we do a couple of things. First of all, we take a look at the operations and do a diagnostic to look for and identify and define the problems that exist that are holding them back from being optimal in their performance. And once we've looked at that data, then we could take a good look at the various causes for why that operational performance isn't where we'd like it to be. And that's really the focus of this presentation. Obviously, coming out of that, once I've discovered causes of poor performance, I may find the need to determine the best ways of eliminating the causes of the poor performance, and then ultimately I have to go put those fixes in place. So solution implementation is certainly where you get the value for all the effort that you've put in. And as I said earlier, we're looking on this particular discussion just to talk about the first half of that is making sure that you don't waste precious time and resources by going straight to solution design and solution implementation. So in our experience, the first thing that you have to know is all the various causes for why performance isn't where it's supposed to be, and avoid jumping to solutions or parts of solutions without being sure that they're directly in response to a known cause. So, a list of things that we often see our clients do, programs of the month, training, root cause analysis training or project management training, solutions that involve technology, purchasing and acquiring new assets, reorganization of your people. All of those may or may not be part of the solution, but the first thing that we've learned is if I don't understand what's going on in terms of the operational diagnostic and why that's happening in terms of the causal analysis, I may not be using optimally my resources to design and implement solutions. So the first tip is make sure you understand the actions you're taking and what they're in response to. A second lesson we've learned before we even get into it is making sure that your efforts are linked to strategic objectives. Saw several questions come in prior to the presentation about this very topic. Most operational improvements ought to be driven by strategic needs, and there's a couple elements of strategic needs that can influence where I focus my improvement opportunities. The first is my strategic planning horizon. So how far out in the future am I looking with my strategy, and how does the operation need to respond to that based on either external or internal factors? So making sure that I'm considering the constraints and the time horizon is critical, and sometimes drives what I could do versus what I should do in terms of improving my operations. Another area of strategy that often drives the need for operational improvement is product market decisions that may have been made. So are we entering new markets, introducing new products? Are we getting rid of old products? Are we exiting markets? All of those may change the context or the picture that my operation needs to fulfill in order to achieve the strategy and make those product market decisions tactically relevant in the marketplace. A third area of strategy is what are the core business processes that need to be improved in order to make a strategic differentiation of my company versus my competitors. So are there business processes that we believe provides a strategic advantage? And if so, what elements or characteristics of that process need to be increased, improved, removed, or whatever to continue to hold that strategic differentiation? And last but not least, your processes are only as good as your talent. So are there skills and capabilities that I either need to add that don't exist today or need to be further developed to make the execution of those core business processes that provide that strategic differentiation in terms of making operational improvements? So all of those things, when I'm selecting what to even begin to diagnose, sort of influence what I'm looking at, what I'm looking for in terms of opportunities and problems, and should drive, obviously, your diagnostic and your analysis activities towards trying to improve the things that the strategy is dictating to you. So talking about the operational diagnostic, and really there's two pieces, the diagnostic and the causal analysis. And when we're talking about the diagnostic piece, really it's a bit different of a slant than looking for root cause in an ongoing operation environment. It's really looking for problems that I may not even know exist today that may be contributing to the less than stellar performance that I'm trying to correct. So knowing that, at the end of the day, it's really nothing more than a troubleshooting effort, but it's a troubleshooting effort that goes looking for problems, is speculating about why, what problems might exist in the organization and in the operations, rather than responding to kind of reported deviations that we often deal with on a day-to-day basis. So before you start the treatment, obviously, you probably got troubleshooting and root cause analysis tools that help you scope and define a problem. So using those tools in a slightly different manner is really the intent of an operational diagnostic, is to find out what problems exist to what degree. So in that same line of thinking, the first thing that I want to do is make sure I unbundle all the various contributors. And one of the things that we find is people kind of look at things as large problems with a single fix, and that's not often the case. And so when we talk about unbundling, it's the equivalent of somebody coming to you as a doctor saying, I'm in pain, and that's not a treatable disease, so to speak. That the pain is merely the sort of the rolled up lagging effect of a variety of different causes. So understanding at the individual level where the different things are that get rolled up and get reported as whether it's OEE or throughput or unplanned downtime or costs are too high or variation is too great. There's a lot of reasons why those conditions and those effects may be in fact the reality, but you need to understand at a very detailed level all the different contributors to what is reported as that pain. Starts with, and this is in any good troubleshooting process, is a good problem statement, a specific object with a specific defect that's going to help you bound the problem. It's going to help you look for multiple different kinds of problems that are solvable and for which solutions can be implemented. So we're really talking about really three different kinds of objects deviations. One thing that may be broken or in need of improvement is the process or the activity. So if I look at a work order process or a material handling process or a setup or a changeover process, I'm going to be watching the business process that is used to execute and produce the output that process is intended to produce. Another type of object that you may be looking at is really the asset or the production process. So the mills or the lathes or the press line or all the different things that are making things in your organization. I may be looking at that machine or that set of machines or that production process as the object. And again, the defect is going to be characterized either by the outputs that come out of it and that are not up to spec, or the activities and the way in which that object or that asset is used. And finally, the object may be a person or a group of people. So my maintenance tech folks don't have good root cause analysis skills, or my supervisors aren't supervising well. So the object is really a person or a group of people. In all those cases, the defect is either an output characteristic or the manner in which the object performs. So an activity or process may be taking too long, or it's incomplete, or the outputs aren't meeting the standards that are set for them. In an asset or production process, you're going to see it run slow, or it produces too much scrap, or the setup is wrong, or it's down to certain conditions. And with a group of people, they don't resolve issues well, or they don't react and report issues on a timely basis. All of those are specific problem statements for which I can go gather data about what exactly is happening that is producing that particular defect. The temptation is very great, particularly in highly automated, data-driven organizations, to gather as much information as possible. And one of the things we find that helps focus the diagnostic effort is to focus on gathering information specifically in a few different categories. And the most obvious and usually the easiest kind of data to get is about the size or the extent of the problem. There's all kinds of data and databases and reports. PLCs are capturing information every second of every day. Most of that information relates to how big is this problem. So how many times does this happen? How large is the defect? How many products are affected as a result of this problem? And that's obviously important information, but there's a whole slew of other information that is relevant. And also, a lot of times the most valuable information is I'm looking for observable activity or performance in terms of what the problem is and what the deviation is, where it's happening, when it's happening. All that information is typically observable to one degree or another, and it's important to understand not just how big is the problem, but also what is the problem, where is it happening, and when's it happening. So making sure that you are getting all of the data that is relevant and excluding information that might be interesting but not relevant to the particular problem that you're trying to find the cause of. Another area of information that's valuable to have is understanding not only the what, where, when, and extent of the problem, but also where that problem could be, but it isn't. So not only looking at just where the problem is, but also where could it be, but it's not happening. And really, there's two uses of that information in the scheme of the diagnostic and the causal analysis. One is that information is very useful for identifying root causes, but also it may lead you to potential solutions. If you've got some similarities in your data and you understand where it's bad and where it's good, what is it about the good that I can use in the area where it's bad? So looking at the what we would call the is and the is not information is also valuable information to go gather and to use in the analysis. So at the end of the day, you're really doing a fill in the blank. So you've got what we consider to be the important areas of identifying cause, which is what information, where information, when information, and extent information in both the is and the is not. And if you're going to spend time asking questions and gathering new information, knowing what answers you want and having a plan to go get those is critical. In addition, you'll have plenty of reports, databases, historical stories and opinions, etc. In our opinion, sort of trust but verify. So the more closely you can get to observing all of the data and all of the information that satisfies these questions, the better off you are. One of the things when I work with a team to do a diagnostic of this sort, if that team is spending the majority of their time in a conference room looking at a computer screen, I know that they're not getting as good information as they could because being out on the floor or within the process or watching the people is really where you get the best information. It's a difference between what somebody reports versus what you observe, and getting that information as close to accurate and real time as possible is really critical to understanding the different causes. Once you've got that plan of attack, now is where, and I'm not really going to get into a lot of the techniques of data gathering, if for no other reason than a lot of organizations already have populated their organization with these tools. So if my goal is to fill in these blanks, here's all the various tools, or at least some of the various tools that I might use to answer the questions that those blanks are trying to answer. So things like throughput and delay analysis, yield, day-in-the-life studies, machine utilization studies, process mapping, waste elimination studies, all those are tools that will give you answers to some or all of the questions above, and making that plan of attack to say, how am I going to conduct these kinds of studies? When I get through with conducting them, which questions in this list of is not, what, where, when, extent will they answer? Will certainly focus your efforts to make sure that you're going to get information that at the end of the day is going to be useful in helping you determine cause. So now that I've gathered information about the problem or problems that I'm trying to fix, what do I do with it? And so a causal analysis, really a good diagnostic, is going to give you relevant information about all the things that we've just talked about. Organizing and sorting it effectively is going to help you come up with hypotheses for why things are happening the way they're happening, and you can use that information to test the suspected cause to make sure, in fact, it is the true cause. And so that's really the thrust of a causal analysis is to make sure that if I suspect this is the reason, does the data support my hypotheses? So as you're doing this, one of the places, certainly there's going to be a lot of knowledge and experience that really speaks to why people think it's happening, and there's going to be plenty of opinions and hypotheses and theories about what that is. If you've either exhausted those opportunities and figured out that they're not the root cause, or if you don't have any idea as to why things are happening, one of the things that we like to help organizations do is look for distinctions or differences around pieces of data between the is not data, which oftentimes leads us to some ideas as to why it's happening. So if it is happening, for example, on first shift but not on second shift, what is different about second shift that I don't see in first shift? Additionally, with each of those distinctions, has something changed about that distinction that also leads us to conclude that a likely cause is coming from that change. Full analysis of the problem requires that the hypotheses make sense in light of all of it. So it's one of the things that has to be done is you have to be able to explain how a possible cause that you suspect is the reason satisfies the facts that you've gathered. And really, when we're looking at those potential causes, a couple of other diagnostic and analysis activities sometimes come out of having that conversation. The first one is I may have some assumptions that I need to go verify of varying degrees of reasonableness. So I can explain why it's happening on first but not second if I assume X, Y, or Z. So I may need to go verify an assumption, make a few phone calls, look at some additional data to see whether or not what I'm assuming is in fact the truth. I may also need to conduct further observations to verify likely causes. So I may suspect something is happening, but I need to go see it to make sure that it is in fact happening. I may need to conduct experiments or tests. So I think this is what the reason is, and if I just do this and I change this characteristic or this variable, that should solve the problem. Why don't we try that for a shift or for an hour and see if that fixes the problem? And the fourth area is there may be the need to try a fix and just see if it works. Certainly that is the higher risk alternatives, but in some cases it may be your only alternative is to try, rely on your likely cause and the probability that it's the truth, and implement a change based on that, hoping that it works, but making sure that you monitor it to make sure it's providing the desired results. Another question that was raised in some of the responses when you signed up was talking about how do you set those goals and how do you identify what the realistic opportunity is. And one of the tools that we use is what we call best demonstrated performance, which is essentially looking at finding a distinguishing characteristics in the high performers. And by that I mean, is there a particular shift that is a high performer? Is there a particular production line? Is there a cycle? So it's a weekly or an hourly thing. Is there a frequency? Looking for when your operation has been performing at its best, and using that as a demonstration that a higher level of performance is achievable. And then if I can raise the rest of the performance to that level, achieving the benefits through raising the bar for the whole operation to a steadier state, so sort of eliminating the variation. And when you're looking at that, really, depending on the kind of improvement you're trying to achieve, looking for either when was the period or the time or the shift or the month or whatever where downtime was least, where was the production highest, where was the yield the best, what kinds of downtimes are higher or lower than others. Again, you're looking for a benchmark that gives you confidence that if everything is right and if all problems are eliminated, I can achieve this level of performance, to give you a sense for how much of the opportunity that's out there is recoverable. And when we talk about best demonstrated performance, not always does the best demonstrated performance achieve the goals that are necessary to achieve the strategic objectives that led you to look at improving the operation in the first place. So I've never performed at a level that I need to be based on the strategic goals, in which case you really only have one option, is you're looking at more radical solutions. So if you can't fix the existing process that's broken enough, you may need to design a new process or make radical, more wholesale changes to the process that you're employing. And it's certainly another option going into the design of a solution is I'm not going to try and fix all the incremental things that are broken with my existing process, because even if I was successful, it wouldn't achieve the level of performance that I need, so I'm going to have to look at a completely different way of doing things. Which leads to the last lesson is the best solutions aren't always the right solutions. So we need to look not only at what the Cadillac of fixes is, but also look at the things associated with the effort to design and implement the solutions that you're considering. So a lot of the times the criteria looks at how much effort or difficulty or cost or the duration of a solution design is required to choose that solution, or other internal constraints like IT or your own internal resources or physical limitations. How eagerly or passively aggressively is change accepted throughout the organization? How radical is the change that we're suggesting, and what are the risks associated with that? So before you start choosing what your solutions are, understand both sides of the equation. And at the end of the day, you've got to balance the strategic importance of making the improvement in balance with the tactical ramifications of designing and implementing the solutions. And so depending on what your organization sees as higher or lower desired criteria, it's going to influence the choices you make. If you're a risk-averse organization and change is very slowly adopted, you may sacrifice some amount of performance improvement in order to have an easier time of implementing something. And the converse obviously is true as well. So again, it's just a couple of things that we've learned over time from how you approach operational improvement, and make sure that you're focusing your efforts in the right directions. Is make sure you understand the causes. Make sure they're linked to something that means something to the business, the strategic value that they're intended to produce. Don't look for the magic bullet. It usually doesn't exist, so you've got to unbundle problems, and you probably have to solve multiple problems in order to achieve the overall performance improvement you're looking for. And make sure you're identifying those specific problems. use your data gathering efforts wisely. There is information that is relevant, there is information that is interesting, and it's the relevant information that you want to focus on by looking at the whole problem landscape. Make sure you have a plan. Again, if you set a bunch of continuous improvement or engineers loose on the floor without a plan, it's going to be a data gathering expedition and spend a lot of time and effort getting information that may or may not be useful. Use the tools that you have. Obviously, if you've gone down the Six Sigma and the Lean journeys, you've got some things in your tool belt that you can use. Just make sure you're using them with a focus on gathering relevant information. The better you can get factual information, obviously, the better off you are in terms of making sure that you've got focused solutions that deal with cause and make sure that those actions have a chance to succeed. And then finally, set realistic improvement goals. If the improvement goal isn't achievable in the current process, if you fixed it, then consider wholesale changes. And then choose your solution design battles objectively. Make sure you understand what's influencing what is considered to be the right solution that you design versus trying to always go for the Cadillac if a Cadillac isn't required. With that, I will turn this back over to Rima for questions, and I'll be happy to take any questions that folks have.
Hi, Brian. Thank you very much for that. Ladies and gentlemen, thank you for being with us throughout this event and for Brian for putting this together. We are now going to open up for a brief Q&A segment. So this is your opportunity, everyone, to get your questions in. All you right-hand side and just send your questions and just by selecting to all panelists. So I'm just going to start us off with a couple, Brian. So there's this first one from Stephen, who it's more of an elaboration than a question he's asked. Could you please explain the difference between diagnostic plan and the data gathering expedition?
The diagnostic plan, let me go back here a couple of slides. Oh, am I able to do that? Yes, I am. Sorry for this. So a diagnostic plan is essentially saying this box, the what, where, when, extent, is not, are the only questions that I want to try and answer about the existing problem that I'm trying to solve. If I'm going to gather information and it's not an answer to these questions, again, it may be interesting, but it may not be relevant. And again, this is just based on our experience in terms of what good problem solving looks like. Is information that doesn't satisfy these questions, doesn't tell me anything more about the problem, or may in fact be information more about the cause, which is again important to get to. But at the data gathering point and the time where I put together a diagnostic plan, all I want to know is information about the current situation, not necessarily the why it's happening or what to do about it. So making sure that I've got that diagnostic plan and I've decided consciously which of these tools, first of all, is capable of providing an answer, and second of all, is worth the effort to go conduct, is really critical to making sure that I'm not just going out there and getting all kinds of information with no ability to sort through it in a logical, rational manner.
Great, fantastic. Thanks, Brian.
Yes.
Steve, I hope that answered your question. Meanwhile, we've had a stream of questions coming in, which is fantastic. And ladies and gents, of course, take your time to send more of our questions in. Before I get to that, I know a couple of people have been asking, will the slides be available post-event? This is just to say that in the next 2 days, you will receive an email just to access the entire presentation as well as a recording of this webinar in case you've missed anything at all. And you'll receive this to access WTG Webinar on demand, and we will send you the link as well as the login details so you can access both the slides and the video. Okay, so moving on. I can see lots of things are coming in. So this next one is from Greg. Brian, he's asked, can you comment on the challenges or differences between operational improvement in an office environment versus a production setting? Yeah,
the biggest difference is going all the way back to object deviation is I find, and this is probably as much my own personality as anything, is production settings are easier because I can physically watch stuff happening. And in an office environment, I'm watching sort of a transactional process. So things are being passed through the boxes and arrows of a flowchart, so to speak. And so the challenges and differences. The challenges in an office environment is you don't often have data that you really, really need. One of the first things I'll do when I'm doing an office environment or a business process is have a conversation, for example, around the 8 wastes, so over-servicing, over-processing, all the kinds of 8 wastes in a lean office environment to get people's opinions as to where they suspect that waste might exist. And then what I often have to do is put in some temporary controls, so some tick sheets that every time you have to do this, just put a mark on this paper so that I can get an understanding of how frequently sort of micro non-value-added activity is embedding itself into the business process. But there's really typically no good electronic data. There's no database that will codify that for me. In a production environment, oftentimes I have a lot of that information because everything in a production environment, especially if it's automated, is being tracked. So it's a lot easier for me to extract information rather than go develop information. The other difference I see is that office environment typically is over a longer duration of time, and so the observation becomes more difficult. And again, it's a characterization, but it seems to hold true in most cases. Is if I'm looking at an accounts payable process, just to pick a generic one, that may happen over the course of a week, whereas in a production setting, in a lot of cases, I can observe, for a shift and get, hundreds, if not thousands, of observations of the same activity over and over. So the volume of observations I could do in a production environment is typically a lot higher and yields more statistically significant information than an operational improvement in an office environment does.
Fantastic. Thank you, Brian. This next question is actually from Brian Deschamps, who's asked, how do you address the system dynamics, such as the effects of interactions between people or processes that may be causally related, but not readily apparent to the people involved in the problem or the investigation?
That's a good question. I'll answer it this way. It's a challenge, first of all. So obviously you recognize that, and it is in fact a challenge. One of the things, and it relates almost to measurement of the problem and to the value of solving the problem. And for you folks not from the United States, I don't know if you've got this program on your televisions, but I ran across this program a few months ago called Bar Rescue. It's a guy by the name of John Taffer who goes into bar owners who are failing and helps them rescue their business. And he had a really interesting experience. He had bartenders who had a really inefficient setup. The taps are on one side of the bar back, the sink's on the other side, the glasses are in another completely different area. And what he did was he set up 2 tape lines, and he said, all right, every time you go outside this tape line, I'm putting $1 in the tip jar. And he had the business owner and the bartenders. The bartenders didn't want to change anything. The bar owner didn't recognize what he was losing. And so he loaded the bar for about an hour or two, and every time they crossed the line, he put $1 in. And at the end of the shift, he said, look, here's what's happening, and here's why it's important, not just to the bar owner, but also to the people within the process that we're asking to change, is this, I think it was $80-some in the jar. He said, this $80 is your tip money. And that means something to the bartender. So you've got to find a way of relating it not only to the bartender, but then he said to the business owner, this $80 represents 80 drinks that your people could have served, but they didn't because they were busy working in an inefficient process. And that costs you X number of dollars based on the margin that your bar gets. Really, in terms of getting those system dynamics and understanding, it's got to be a common goal that means something to different populations of people. And finding that obviously is very hard, but finding out in a manufacturing process is what would represent a better work-life status if it were fixed in the operation at the operator level, but also making sure that you understand what's the value to the business if that improvement is achieved simultaneously.
Great, fantastic, thank you. Brian, this next question from Paul, he's just asked if you could please elaborate on the current slide that we're on. He's mentioned that the is not dichotomy. This chart is new to him, so if you could please just explain a bit more.
Sure. Real simple example in terms of how to use is and is not information to your advantage. If you came home to your house and walked in the door and flipped on the light switch and it didn't go on, what would that tell you? Well, it would tell you that you can't see. The next action you take in terms of looking for cause would be what? Probably go to the next room, right, and find out if that light switch works. And if it doesn't, what does that tell you? Well, then I'm probably going to go down to the basement and look at the fuse box to see if my fuse is blown. And if that doesn't fix the problem, then what am I going to do? I'm going to look out in the neighborhood and to see if my neighbors have power. All of those are bounding the problem that you're looking for by understanding where the problem is and where it stops and it no longer is or is not, gives you better information and further defines the problem itself and gives you some ability to analyze what might possibly be the cause. So when you walked in the door, it might be the light bulb, it might be a particular fuse, it might be power out in the neighborhood, it might be global catastrophic power failure. And knowing where the problem is bounded and where it stops and where it starts is critical to that diagnosis.
Fantastic. Thanks, Brian. And Paul, I hope that was a little bit clearer this time around. Brian, this next question is from Mark Wilson, who said, we have much experience with Lean, Six Sigma, and in-house processes, but the human factor seems to play a big role. What process or experience do you have to maintain gains that are made during the focused efforts?
A couple of things. First of all, understanding why people behave the way they behave in terms of a diagnostic is certainly a kind of study, and I don't mention it on this particular slide, but there may be a variety of models. We happen to have a model called the performance system. And all the performance system does is it says, okay, so somebody is performing or behaving in a way that is undesirable. And assuming they're not doing it to be insubordinate and are just being a real pain in the rear, there's got to be something else going on that causes them to act in that way. And so the model really looks at a couple different elements that can be influencing why people are behaving, behaving that way. One is the consequences they experience as a result of that behavior. So do I get encouraging consequences, both short and long term, for behaving the way and performing the way I'm supposed to, or are there cases where it's less painful for me to not do the right thing, which is encouraging me to underperform or not perform in the way I'm supposed to? We look at the feedback they receive. So do they get good pinpointed feedback about their performance? Do they understand the impact of that performance on the overall goals of whatever it is they're working in, so that they can change how they do things and perform differently? Are there situational elements that are making that performance be the way it is? So do I understand performance expectations, and do I agree with those performance expectations? Have I done my best to eliminate task interference? Do I understand the priorities in terms of the behaviors or the performance that I should be exhibiting and the relativity of each? So really using you almost have to start with let's assume this person or this group of people didn't come into work with the sole intent of screwing it up as much as they possibly can, and then let's talk about the various reasons why it's not happening. Now, from an implementation standpoint, making sure that the changes stick and are sustainable, that's really dealing with that performance system and that model can be changed, and understanding what needs to change in order to influence. It's a predictive model, so if I change these elements surrounding the performer, then I can predictably assume that their performance will respond in this way. So understanding the performance system and how to change it to make it less painful or not painful at all to do the right thing is really the challenge. There are challenges around coaching. You may give them a process which looks great on a flow chart. You may give them a new tool which works great in a classroom. It's different using those skills and capabilities and those tools out in the real world. So making sure that you provided coaching and help them to understand the nuances of what it's like to use it outside of sort of a clean environment or a vacuum is really the second element of sustainability. And the third one is really the leadership alignment. If the organization as a whole doesn't agree that the level of importance that there is associated with the changes that you're asking people to make, doesn't understand the impact, doesn't understand the amount of time and effort and resources and money that need to be expended to affect that change, then you're in for a program of the month, quite honestly. And it's really crucial that leadership up and down the ladder, so to speak, needs to be aligned around what the impact of the change that people are being asked to make has on all those various levels and all those different populations.
Great. Thank you, Brian.
Sure.
Brian, you've been so great at getting so many answers across, and of course I wanted to remind everyone that, due to time constraints, if we don't get to all of your questions, we do apologize, but of course a full list of all your questions will be sent to Brian. So I'm sure Brian over at Kepner Trigo will be able to, and his colleagues would be able to get in touch with you offline regarding any specific queries you might have. Before I move on to the next question, Brian, can I please request you to just move on to the very last slide where your contact details are? I just wanted to give everyone, all of our attendees, just a quick minute to jot down your details. If there's any specific questions or queries you may have, you're welcome to get in touch with Brian via email or on his number that's noted there. Now, just moving on to this next question from Alex Merritt, who's asked, Brian, do you have any key tips on how to quickly determine what data to eliminate so you're not overwhelmed with all of the information?
Well, it's another very good question, and I hate to rely on the old consultant standby, but it depends. Depending on the nature of the problem, sometimes the where information is more important and the when information not so much. Other times the opposite is true. So understanding, I guess what I typically am looking for is a really sharp contrast that leads me to have a high level of confidence in the probability of a cause. So for example, go back to it's happening on first shift but not on second shift, or it's happening on this press but not that press. That to me is intriguing information because I can go observe both sides of the is not, and I probably don't need to spend a lot of time looking, for example, at extent information. I'm looking more at the activities. So it really the data it's even in the presentation, we've outlined it sort of as a very serial process. It's a very iterative process in reality. Is I gather some data, I see what it tells me, and then I figure out where I need to know more or more specific or different information to satisfy more discreetly a question that I'm trying to ask of the data. So it is not a matter of you go out, gather data one time, and you go into a room and magically out pops the answer as to what the causes are, and you go fix it. If it were that easy, we'd probably all have a lot easier time in life than we do. So understanding what you know, and then also the other thing, I guess, is understanding what you don't know, and do you need to know it. So there are times where I can't answer all of those questions in terms of what, where, when, extent is not. And you've got to make a value judgment as to whether or not the level of effort I need to expend to go get that answer is going to give me better information with which to start looking at the likely causes and talking about how to eliminate them.
Fantastic. Thank you, Brian.
Mm-hmm.
And Alex, I hope that was quite useful. Lots of great tips there. I know we are going to be wrapping up shortly, so I just have just a few more questions for you, Brian. So the first one here is from Marco Guerrero, who's asked, once a change is made, for how long should we monitor it to ensure that other problems are not created? 2
minutes. No. It's a great question. It's what we happen to call think beyond the fix. Is a change I make here may have ramifications and implications down the line or further along in the process. It depends on what your cycle time is, and not in the strictest definition of the word, but how. So for example, in a manufacturing operation, it may be a matter of a week, so that I make sure I cover all shifts. It may be a matter of a month because I don't run this product other than once a month. So it really, I hate to use the old "it depends" line again, but it really depends. The important thing when you're designing the implementation of these solutions is to develop that monitoring plan. Just because I issue a memo saying on Monday start doing it this way doesn't mean it's going to happen, and there's a lot more that goes into it than that. So making sure you have set up sort of the process management piece of process or solution design that says, how am I going to know when this thing is starting to fail? Are there leading indicators that start to show me some minor degradation in performance before it gets to an end-of-the-line lagging indicator that tells me that the whole thing is screwed up? So it's really a matter of putting in place the amount of control with a balance for the amount of effort it takes to monitor that process, depending, again, on its importance, the importance of that change to the overall performance of the process itself, if that makes any sense.
Thanks, Brian. We have quite an interesting question here from Brian Deschamps again, and this is a question that might be on the minds of some of our other attendees. So he's asked, when a process is stopped due to a significant problem, how do you balance the urgent desire to get back to work with the need to take the time to thoughtfully work through the investigation and develop long-term solutions?
That's a great question. A couple of things come to mind. One is certainly health and safety comes first. So that's it almost goes without saying, but it's important to understand that is making sure that the damage is contained as quickly as possible. The second thing that comes to mind is what can I learn from that significant problem? What can I capture about either why it happened based on the information that I have available, or how I solved it, or what some alternatives were, or what other things could go wrong. All the things that are you're sort of not focused on because you're trying to fix the immediate problem are most likely giving you really good information that allows me, once I've contained the damage, to go back and think about it for a while and talk about how can I put in place a longer-term solution based on what I learned from this particular event. But at the end of the day, all of these improvement efforts usually have to live in a world where you've got to keep the trains running. You're probably not having a lot of full-time resources dedicated to the long-term solutions because they all have day jobs. All of that's going to be balanced not only with the individuals and their performance system, so to speak, but also with the importance of the long-term solution to the overall strategic objectives, and what are you putting at risk in the short term based on not looking at the long-term solutions. So relating it back to those strategic objectives and saying, is it important enough that if I just contain the damage for now, it's more important that I work on the long-term solution and live with a slightly degraded performance today because of this significant problem, knowing that I'm putting in place a longer-term solution to prevent it from happening in the first place later on down the road.
Thanks, Brian.
Mm-hmm.
Brian, this next one's from John. I hope you're not getting too tired from
No,
all
not
the
at all.
questions that are coming in. So this one's from John Schaffer, who's asked, what if you're satisfied with the process, but it can be improved? What is the starting point for identifying the improvement opportunity?
What I would do is use a process that Kepner-Trigo calls potential opportunity analysis. So let me talk a little bit about that for a second. As I mentioned, I think on a next to last slide, is I may, at the end of my diagnosis, figure out that the process is working as designed. It's just that the design is poor. So really looking for what kinds of effects or what kinds of performance am I hoping to create? If I wanted to intentionally cause that performance, what kind of actions would I take? So it's a matter of looking at the kinds of things you can introduce to a stable system that will create a variation that happens to be positive in nature. And as well as that is how would I capture the value if I am lucky enough to be able to create that higher performance to make sure that all the effort I put into creating it doesn't get lost because I wasn't able to capture it. So if I think about, I'll just give you a real quick example. If I look at a shutdown process, and typically in a shutdown process you have lots of OEMs and contractors and skilled tradesmen coming in and doing all kinds of stuff. One of the things I look for when I'm trying to redesign my shutdown process is how can I create the opportunity for the contractors and the OEMs who aren't there every day to finish early. And if I created that opportunity, what would I do with them? Well, I would probably have them do some unplanned maintenance because the machines are down and I've got that availability. So what are the things I can do to create that? And it's typically things that are process driven in terms of, setting up the staging and making sure that all the folks are coordinated and having a plan, the logistics of it all the things that you would do to create the opportunity that they might finish early and have some extra time available that I could take advantage of. So it's really thinking from a more opportunity perspective as opposed to solving a problem perspective.
Fantastic. Thanks, Brian. I think in a similar vein, we've had this next question asked, which is, Brian, what are the top 5 potential improvement categories for a plant that is not usually operating at capacity?
That again is going to be driven from strategy. So I'm assuming from this question, if you could make more, you couldn't sell it is the situation that you find yourself in. In other words, you're not a capacity constrained organization. So that tells me right away that a couple of things. One is, can I find something to fill that capacity? Or find ways of taking that extra capacity and using it elsewhere, which may or may not be, depending on your operation, your situation, may not be an option. It also tells me that you're probably not in a commodities type situation. So are there further improvements you can make to how that process operates that improve either the quality or the throughput or the cycle time as opposed to but primarily the quality, because I'm assuming if it's not a capacity situation, that your differentiator is the quality of your product, not necessarily the low-cost nature of your product. So in terms of the top 5 categories, I mean, certainly quality is the one that jumps out at me based on the nature of the question. I would also look at least internal cost reduction in terms of how can I more effectively utilize my resources knowing that I'm not in a capacity-constrained situation to do something else that adds value to the organization and to the operation. Those are really about the only 2 that really jump out at me in terms of that question.
Thanks, Brian. We have, before we sort of start wrapping up, we have these final 2 questions from Deborah Kemp and Alex Flux. So this one's from Deborah. She's asked, do you prioritize based off the critical chain or critical path, or do you first go for the low-hanging fruit?
Again, it depends. If my strategic objective is to shorten the cycle time or shorten the lead time, I would certainly look at the critical path or the critical chain first. In other words, I'm going to look for all the non-value-added activities along that critical path that I could possibly eliminate in order to shorten it. If that is not my primary strategic objective, I may look for low-hanging fruit. Now, having said all that, the culture of your organization, I think, plays a role in answering that question. Is do I need to show some quick wins early to get people bought in, knowing that the critical path route is going to be a bit more difficult and maybe more strenuous in terms of looking for improvements? And if so, I tend to take the quick wins first and use that as a motivation for kind of tackling the more complex, more intricate problems that are associated with getting rid of non-value-added activity.
Thank you, Brian.
Mm-hmm.
And just wrapping up, this is the final one from Alex, who's asked, in a just-in-time model, because of all the variables, So in a just-in-time model, because of all variables, where should the focus be in not only data collection, but also in solution implementation?
Data collection, I'll start there. In a just-in-time model, the data collection really is looking in a just-in-time environment, a problem manifests itself at exactly the wrong time, which is the thing I need right now isn't there. So the data collection I typically look for in a just-in-time environment is working back that value chain to see where I can find reasons why I may be jeopardizing the just-in-time nature of the delivery of the output that process is trying to produce. From a solution implementation, they're very difficult, to be quite honest with you, because you are kind of living on the edge in a just-in-time model in the first place, and making changes. So I focus not only on the implementation of whatever solution I've designed, but also in protecting the ongoing operation. So whether it's I do inventory builds ahead of time, knowing that I'm not going to be running optimally the first couple of days or weeks or whatever of the implementation. I focus on redundancies, or at least temporary redundancies, to make sure if this solution that I'm trying to implement fails miserably, I'm not out of stock, or I'm not I haven't eliminated the ability to do it even in a less effective manner. So it's really in a just-in-time model. Again, it's a very if it's designed well and it's balanced properly, you've got to be very careful in the implementation that you don't shoot yourself in the foot, even if you're trying to do the right thing by implementing a new solution.